So I'm at the Catalunya Formula One track in Barcelona, where we'll be filming one of the most extreme maths lessons ever attempted. I'm going to be driving the Williams FW33. This car is a beast. It accelerates from 0 to 60 miles per hour in under 2.3 seconds and 0 to 100 miles per hour in only 3.5 seconds. Now, turn 3 of the Barcelona track is so fast it's taken in 5th gear, and you do over 150 miles per hour. Whereas turn 11 is taken in 3rd gear and is a much slower corner. We're going to calculate my average speed around these two corners using the actual distance time graph of my Formula One laps around the circuit. In this question, we're asked to calculate the average speed at turn 3 and turn 11. And this is the actual distance time graph of my Formula One lap around turn 3 of the Barcelona track. Now, there are two different ways to calculate the average speed from a distance time graph. The first way is by using the formula speed equals distance divided by time. And we can put this formula into a formula triangle. So we can see here that distance is on top of this divide line. And remember, in a formula triangle, this line here is a divide line. So we need to put distance on top of this divide line, and then time goes on the bottom. So I'm going to put time here, and then we put speed in the gap that's left. Now, the second method to calculate the average speed from a distance time graph is to calculate the gradient of the line. Because on a distance time graph, the gradient of the line is equal to the speed. Now, I'm going to start by teaching you the first method, which was using the formula to calculate the average speed at turn 3. So to calculate the speed, we need to work out the distance and the time for turn 3. And to do that, we're going to have to read off some values from the graph. Now, this is the line for turn 3. And hopefully you can see that it starts at 0. So the first thing that we're going to do is work out the distance of turn 3. So to do this, we need to go to the end of the line for turn 3, and then we need to go across the graph, and we need to read off this value from the y-axis, which is the distance. But remember, any time that we're reading off values from a graph, we must draw a dotted line on the graph using a ruler and a pen. So I go to the end of the line of turn 3, and I take my ruler, and I need to draw a dotted line from the end of this line across the graph until I get to the y-axis. And this is the value of the distance that I need to read off. Now we can see that it's halfway between 500 and 400, which means that this distance must be 450. So we now know that the distance of turn 3 is 450 meters. And we need to divide this by the time. And to work out the time, we need to do exactly the same. So we go to the line for turn 3, and we go to the end of the line, and this time we need to go down the graph until we get to the x-axis, which is time. But remember, any time that we're reading off values from a graph, we must draw a dotted line on our graph. So we go to the end of the line for turn 3, and we take our ruler, and we draw a dotted line down the graph until we get to the x-axis. And this value here is the value for the time. So we can see that this is exactly halfway between 6 seconds and 8 seconds. So the time must be 7 seconds. So we write 7 seconds here for the time. So to calculate the speed, we need to do 450 divided by 7. Now I do this on a calculator, and it equals 64.29 to 2 decimal places. Finally, to complete my answer, we need to put the units of speed. Now, because the distance was measured in meters and the time was measured in seconds, that means that the speed will be measured in meters per second. So my final answer is 64.29 meters per second. Now, meters per second is a very popular unit for speed in maths and physics. But in everyday life, we don't really use meters per second. We'd use miles per hour or kilometers per hour. And 64.29 meters per second is approximately 144 miles per hour. So turn 3 was a very fast turn. Now, the units of speed always depend on the units of distance and the units of time. So if in this example we changed the units of distance to kilometers, and if we changed the units of time to hours, then that would mean that the units of speed would now become kilometers per hour. So always make sure that you look at the units on the axes of your graph. Now, in harder questions like this, we need to carefully look at the units that we're given on the axes of the graph. So we can see here that the units for time is in seconds. And that's exactly what we want the units of time to be, because the units of speed is meters per second. But if we look at the units for distance, we can see that the distance is measured in kilometers on the graph. And we don't want the units to be in kilometers, because the speed is meters per second, which means that the distance must be measured in meters. So when we're reading our values from this graph, we need to convert 0.45 kilometers into meters, which is 450 meters. And then, as long as your distance is in meters and your time is in seconds, then your speed will be in meters per second.